In this video, I'm going to derive this form, this geometric form of the dot product using trigonometry. And so I've got two vectors over here, and we can connect these two by another vector c. And notice that this is not a right triangle now, so we can't use our basic trigonometry functions, but there is something called the law of cosines. And I'm not going to prove the law of cosines in this video, but it's something in trigonometry that looks like this. So if you have c squared is equal to a squared plus b squared. Does that look familiar? That is Pythagorean's theorem, except it's got an extra term on here. Minus 2ab magnitudes cosine of theta. And so this is the law of cosines. And what it basically is Pythagorean's theorem, but generalized to non-right triangles. So you can use this to find the side of any right triangles if you know two of the sides and the angle between those vectors. So what I'm going to do is use this to derive our dot product. So the first thing to notice is that C, based off the nature of vectors, is the same as A minus B. So the magnitude of C is the same as the magnitude of A minus B. So I'm going to plug this in here. So A minus B squared is equal to the right side here. Like so. Now, what we can do is take a look at this and we can expand this out. So I'm just going to look at the left side and I'm going to note that A minus B is equal to, the magnitude is equal to A minus B times A minus B. Now you might ask why. So I've got this is the magnitude here. This should be squared. This is the magnitude squared. Why isn't it the magnitude of A minus B times the magnitude of A minus B? Because I'm just subtracting the vectors here with no magnitude. The answer is because if you look at C squared is equal to C times C, what you're doing here is you're basically just taking C cos theta, where this is simply C squared, because this goes away. This is 1 because they're in the same direction. Theta is 0, so cos theta, if I write it more clearly, is 1. So that's why you can say that the vectors multiplied by each other is equal to the magnitude squared, and that's what I'm doing here. So if we expand this out, we can multiply the terms with each other. So A times A dot A that is, minus, because there's a negative, A dot B minus B dot A, and then plus, because there's a double negative, B dot B. Or, because you can take A dot B or B dot A, they're the same. So we can combine those to be minus 2 A dot B plus B dot B. Okay, so this is now what we have on the left side. So I'm going to put this back into this equation. And actually, one more step. A dot A, like we did back here, is just the magnitude of A squared minus 2 A dot B plus magnitude of B squared. So that's what I'm going to plug back in for A minus B squared, the magnitude. So if I write that all out, I get this on the left equals this equation. Sometimes it takes a while to write everything out. And we have this. So notice we've got the same terms on each side. So what we can do is this cancels out with this cancels out with this, and what we're left with is negative 2 A dot B equals negative 2 magnitude of A times magnitude of B cosine theta. The negative 2's cancel out, and we're left with A dot B is equal to the magnitude of A times the magnitude of B cosine theta. And that's our dot product. So that's how we can see how it actually comes from math. Like in the last video, I kind of just said, this is the formula, and it might confuse some people and they might say, hey, like, where did that come from? This is where it comes from. It comes directly from the laws of trigonometry. So thank you for watching.